we're going to solve three-part inequalities and write our answer in interval notation. So with this first example, -3 less than or equal to x plus 2 less than 5. So our goal here is to get x by itself in the middle, sandwiched between a couple of numbers, when we're solving a three-part inequality. So in this case, I've got x plus 2 in the middle there. So to get x by itself, I need to subtract 2, right? Now, what you do to one side, you do to all sides in the case of a three-part inequality. So I'm going to have -3 minus 2 less than or equal to x plus 2 minus 2 less than 5 minus 2, right? So I just subtracted 2 from all of the sides. So over on the left, -3 minus 2 is -5 less than or equal to x less than 5 minus 2 is 3, right? So I have -5 less than or equal to x, and x is less than 3. Okay, now with a three-part inequality, it's the need to do anything on a number line to see what you've got is not needed, right? Because we can see easily that x is between -5 and 3, and the solution set is -5 to 3, and I'm including -5, so I'm using a closed bracket there, and I'm not including 3, so I'm using an open bracket there. Okay, so that's the basic idea. So let's do a harder one. All right, so over here we've got 4/5 less than or equal to 4 minus 2m all over 10 less than or equal to 2. Okay, so you got some fractions involved. And remember, it's the same concept as when you're solving an equation. What you do to one side, you have to do to all sides in this case. So I'm looking at the denominators, and the first thing I want to do is just get rid of the fractions. So I've got 5 and 10 as denominators. So our common denominator would be 10, right? So I'm going to multiply all sides here by 10. That'll be easy. Okay, so 10 divided by 5 is 2, and 2 times 4 is 8, right? And in the middle, the 10's cancel, so I'm going to be left with 4 minus 2m. And then over on the right, 2 times 10 is 20. Okay, so I end up with 8 less than or equal to 4 minus 2m less than or equal to 20. All right, and notice we changed up the variable too. We've got m instead of x. Okay, so now we want to continue to try to get m by itself in the middle, right? So I want to subtract 4 from all sides. 8 minus 4 less than or equal to 4 minus 4 minus 2m less than or equal to 20 minus 4. 8 minus 4 is 4, less than or equal to -2m, less than or equal to 16. Okay, so now I'm still trying to get that m by itself. I have to divide all sides by -2. Okay, what happens when you divide by a negative number? We have to reverse the signs, right? So 4 divided by -2 is -2, greater than or equal to m, greater than or equal to -8. So in reversing the signs, you got to reverse all of them, right? And the statement that you have in the end should make sense. All of the inequality signs should be pointing toward the lowest number, right? So we're saying -2 is greater than or equal to m, greater than or equal to -8, right? -8 is the lowest number on the number line. Now, if you wanted to write it so that the lowest number comes first, right, because that's easier on the eye, you could say -8 less than or equal to m less than or equal to -2. It's the same statement, right? So if you reverse those numbers, make sure you reverse all the inequalities with it, right? But we now know that m lies between -8 and -2. So the solution set is -8 to -2, and I'm using closed brackets on these intervals because I have less than or equal to signs. Okay.